Please, am I reading the objectives with the answers?
No, you just the questions.
Okay. Question 1. An indifference curve represents bundles of goods that a consumer.
All right, so we know that indifference curves are just locus of bundles of goods that fetch the consumer the same level of utility. So in the eyes of the consumer, any bundle on the indifference curve is desirable. It gives him or her the same level of satisfaction. So that should be C. Okay, the consumer views those bundles as equally desirable. Okay, so the question 1 should be C.
Question 2. The assumption of completeness means that.
Okay, so this means that the consumer is able to rank all the affordable bundles, okay, in his or her opportunity set. If the bundle isn't affordable, then there's no point in comparing it to affordable ones. So this assumption means that the consumer can rank all affordable consumption bundles. Okay. They can rank all the affordable consumption. So number 2 should be A. 2 should be A. All right.
Question 3. If a consumer prefers apples to bananas and prefers bananas to citrus fruit, in order to satisfy assumptions about preferences, she has to prefer.
All right, so this one too is talking about the axiom of transitivity. If you prefer apple to banana and then banana to citrus fruit, then per the axiom of transitivity, you need to prefer apples to citrus fruit. So hypothetical syllogism, apples are supposed to be preferred to fruit. So D, the D.
Question 4. If two indifference curves were to intersect at a point, this would violate the assumption of.
Okay, so this is what they mean. Assuming this is one indifference curve, okay? This is another one, and then we have a different one here too. Let's call this indifference curve C. This is B, and then this is A, okay? I'm sure by looking at these indifference curves, this one should be on a higher utility than this one and also than this one. But because they are meeting here, any bundle here, if you take bundle A, then the consumer is supposed to be indifferent between all these indifference curves, which shouldn't be so. So if they intersect like this, then they are violating the transitivity assumption. Okay, this must be preferred to this, and this one too must be preferred to this. But if you look at a point here, the person should be indifferent between all these, between any bundle on this indifference curve, which shouldn't be so. Okay, so the axiom of transitivity is being violated. All right, Sandra.
So please, this question. When I saw if two indifference curves were to intersect at a point, I was thinking maybe two indifference curves crossing each other. You see that one too, there's a point they intersect.
Yes,
but
yes,
even
that
so,
one
if
too.
you
That one too violates the axiom of transitivity. Yes, I think if you check the first meeting, if you check the video, I think there was a question like that, where we're supposed to use a diagram to talk about the logical inconsistency that happens when indifference curves cross each other. They violate the axiom of transitivity. All right.
Question 5. A consumer's willingness to trade one good for another can be expressed by the consumer's.
Right. So if you have two goods in the two commodity case, we use the marginal rate of substitution to measure the willingness of the consumer to trade one good for another good. Okay? So assuming we didn't have any possible answer like the indifference curve, then it should have been the marginal rate of substitution, but we get the marginal rate of substitution from the indifference curve. Okay, but there are some indifference curves where we don't even have any marginal rate of substitution. If the indifference curve is L-shaped, like the case for a left shoe and then a right shoe, there's no rate of substitution at all. Okay, but this one, because we derive the marginal rate of substitution from the indifference curve, I chose C, that it is depicted or expressed by both the indifference curve and then the marginal rate of substitution, since we are getting the marginal rate of substitution from the indifference curve. But this is one of the questions that I wasn't so sure of. But left to me alone, I would have gone for C, both the marginal rate of substitution and in the indifference curve. So later on, you can also check and see what you have. All right. All right, number 6.
Convexity of indifference curves implies that consumers are willing to.
All right, so for the consumer behavior, most of the analysis is centered on convex indifference curves, which means that there is a diminishing marginal rate of substitution. Okay, if you have a typical, I'm coming. If you have your typical convex indifference curve with the vertical axis measuring units of y, and then the horizontal measuring units of x. Okay, we say we have a diminishing marginal rate because as you move down the convex indifference curve, the willingness of the consumer to sacrifice more y for x decreases. So if, for example, the marginal rate of substitution at this point was 10, but by the time you get to a point here, it should decrease to say 5. And the reason is that as you see this 10 here, this 10 measures the units of y that the consumer is willing to sacrifice for just an additional unit of x. And here he is willing to sacrifice this much because he is consuming too much of y and too little of x. So because he's consuming too much of y, he feels like it's okay when you sacrifice more units of y. But as you are moving down the indifference curve, by the time you get to a point here, you'll be consuming more units of x and less units of y, which means that you will not be sacrificing and you will not be willing to sacrifice the little y that you have for x. That is why the willingness decreases as you move down the convex indifference curve. Okay, so the convexity means that the person is willing to give up more y to get an extra unit of x, the less x that they have. So if you are at a point like this, you see that you are consuming more y and less x, so you'll be willing to give up more y for just an extra unit of x. So the answer should be D, give up more y to get just an extra x when you are consuming less of x. Okay, so it should be for D. All right.
Question 7. Diminishing marginal rates of substitution can be seen with indifference curves.
All right. I'm sure by now we all know that not all indifference curves are convex. Some are straight lines, some are even L-shaped. We only have diminishing marginal rate of substitution when the indifference curve is convex. Okay, the marginal rate of substitution only falls when the indifference curve is convex. If you have the indifference curve for perfect substitute, it's just a straight line, and the marginal rate of substitution is constant. It's always -1. So it's only with convex indifference curves that we have diminishing rate of substitution. So that should be C.
Question 8. If two goods are perfect substitutes, Then the indifference curves for these two goods would be.
Okay, so for indifference case for perfect substitute.
Hello.
Yes.
Sir, please, can you go over the 7 again?
Number 7, eh?
Yes,
And the
please.
6, please. And the 6.
Okay, it seems they are all talking about the same thing. So this is what I'm trying to say. If you have a convex indifference curve, okay, it means that there's some level of substability between good Y and then good X, okay, which means that you are willing to sacrifice 1 unit for the other. Let's assume the individual is consuming bundle A. Okay, for bundle A, the person is consuming more unit of Y than the units of X. So just assuming you are consuming 2 goods, okay, you are consuming so much of one and too little of the other. This means that you'll be willing to sacrifice more of the good that you are consuming for just an extra unit of the one that you are not really consuming, which means that the marginal rate of substitution, which measures the consumer's willingness to sacrifice one good for the other, will be very high here, which means that because he's consuming too much of Y, he'll be willing to sacrifice more units of Y just for an extra unit of X, because the units of X that he's consuming is very little. But as you move down the curve, the convex curve, assuming we get to this point, point B, here you realize that you are consuming so much of X and so little of Y, which means that your willingness will decrease. If here you were willing to sacrifice 10 units of Y, maybe here you just be willing to sacrifice only 1 unit of Y for an extra unit of X. And the reason is that you are consuming so much of X, so you don't really need X, but you are consuming so little of Y, so you need more Y. You shouldn't be willing to sacrifice additional units of Y for just 1 unit of X. I hope you understand me now.
Yes, please.
And so to answer the question, if you are asked of the reason behind the convexity of an indifference curve, it means that the person is willing to sacrifice more unit of the good that he is consuming more just for an extra unit of the good that he is consuming less. Okay, so they are willing to give up more of Y to get an extra unit of X when they are consuming so little of X. Okay, that is for the 6. Okay, that is for the 6. And for the 7, we have diminishing marginal rate of substitution when the indifference curve is convex. This is the marginal rate of substitution that I was talking about. But as you are moving down the indifference curve, the MRS diminishes, it decreases, because your willingness to sacrifice more Y for X will be falling. That is what the diminishing marginal rate of substitution means. Okay, but if you have an indifference curve like this, okay, for the perfect substitutes, something like maybe Coke and then Pepsi, the marginal rate of substitution is always -1. You sacrifice 1 Pepsi for 1 Coke, just like that. Okay, you are not willing to sacrifice 2 of this for just 1 of the other, because they all satisfy the same purpose. So if you don't want to go for A, then you are going for B. If you sacrifice 2 units of A, then you have to get 2 units of B in return. Okay, so for perfect substitutes, the marginal rate of substitution doesn't diminish, it is constant. If you have L-shaped, there's no level of substability at all. Something like your left shoe and then your right shoe. How can you sacrifice one for the other? No, they are supposed to be consumed together. So there's no level of substability. Okay, so we only have diminishing marginal rate of substitution when the indifference curve is convex to the origin. Is that okay? Right. I hope we understand it now.
Yes.
Right.
Yes, yes.
So the answer is convex. Okay. They have to be convex. All right. Diva.
I read the question. Should I read it again?
Yes. Now I.
Okay. If two goods are perfect substitutes, then the indifference curves for those two goods would be.
They have to be downward and straight. Okay. Like the example I just gave for Pepsi and Coke. It's straight. It's downward and straight. Okay. So it's supposed to be D. Downward and straight. Please, you have to remember indifference curves cannot be upwards. They violate the more is better assumption. Okay, so C is not even part at all. And then this one is convex. This one is for goods that are jointly consumed. So the answer is D. They are downward and straight. All right, number 9.
The indifference curves for left shoes and right shoes would most likely be
L-shaped. Okay, they are consumed together, so it's L-shaped. So like ice cream and pie, okay, assuming they are perfect. So if that's the case, they have to be consumed together. You can't just consume one and leave the other. So they are most likely to be L-shaped. All right, number 10.
Question 10. If Fred's marginal rate of substitution of salad for pizza equals 5, then
Right, so this one too, the marginal rate of substitution is the marginal utility of X over the marginal utility of Y. And it measures the units of Y that the individual is willing to sacrifice just for an extra unit of X. So we've been given the marginal rate of substitution of salad for pizza. So salad is X, pizza is Y, and the value is 5. This means that the person is willing to sacrifice 5 units of pizza just for an extra unit of salad. So that should be D. He will give up 5 pizzas to get just the next salad. Okay. So please take note of the interpretation of the MRS. The marginal rate of substitution of X for Y is talking about the units of Y that you are willing to sacrifice just to get an extra unit of X. Okay, so that should be D. All right.
question 11. If the utility for two goods, X and Y, is measured as U is equal to X plus Y, then it can be concluded that.
All right, so this means that before you get your utility, you have to consume both good X and then good Y. It means that these two goods are being consumed together. So that should be C, okay? That should be C. You have to consume both X and Y before you get your U. If you consume only X and no Y, you wouldn't get the level of satisfaction that you want. So with X and Y are supposed to be consumed together. So we go for C. Go for C. Number 12.
Joe's income is $500. The price of food, F, is $2 per unit, and the price of shelter, S, is $100. Which of the following represents his budget constraint?
All right. I think someone is saying number 11. Number 11, what I'm trying to say is you see that the level of utility depends on consuming both goods, consuming both X and then Y. Okay, so before you can get this your level of utility, it means that you need to consume the two goods. At least that's what I know, that you have to consume these two goods before you get your level of utility. So if you have to combine, when you do production to and isocons, types of isoquants, I think you see something like this one too. But still, you can also try to verify. Right. So for the number 12, they are only looking for the budget constraint. Okay, and we know that the consumer's income should be equal to the sum of the expenditures on the two goods. Okay, so this is the price of is it food times the quantity of food, then the price of shelter times the quantity of shelter. This should be the individual's budget constraint. Okay, so the income is 500. We have 500 here. We have been given price of food as 2, so we'll have 2F here. Then the price of shelter is 100, so we have 100S. Okay, so I think that should be B, right? B, 500 is equal to 2F plus 100S. So this is the budget constraint. Okay, so that should be B. That should be.
Question 13. Joe's income is $500. The price of food
The brain.
Yes.
Please, can you go over the 11 and 12? My network was very bad.
For the sake of network, that one you have to watch the video later. As for this one, I'll go over, but subsequently I can't, because if we have to be going over whenever networks mess up, I think we can't get anywhere. So later on, you can just refer to the video and then go over.
Okay, thank you.
For the number 12, we have been given the income level, the price of food, and then the price of shelter. They want us to state the budget constraint. And the budget constraint states that your income level should be equal to your expenditure. Income has been given as 500, so that's what we have here. Expenditure on food is the price of food times the quantity of food that you buy. That is 2F. And then the expenditure on shelter should be the price of shelter times the quantity of shelter. That is S. So that should be 100S. So the budget constraint is stated as this, the B. Okay, B. And then for question 11, I think you should try and go over it yourself, because someone raised a concern that he thinks it has to be perfect substitute. So you can verify and see. It should be B between B and then C. Okay. All right, Jifa number 13.
Joe's income is $500. The price of food F is $2, and the price of shelter S is $100. Which of the following bundles is in Joe's opportunity set?
All right, so we need to know what the opportunity set is. It talks about all the bundles of the two goods that are affordable to the consumer, which means that whichever bundle that you choose, the expenditure on that bundle should be less than or equal to the consumer's income. This is multiple choice, so you can just use the elimination method to get your answer. You just pick the first one, insert them into the budget constraint, and see if the expenditure will be less than or equal to the consumer's income. If you take 200 units of food, then the expenditure on food is going to be 2 times 200, which is 400. And then 2 times shelter, the price of shelter, that will be 200. So if you add the two, we are getting 600, which is more than the income of 500. Okay, but let's choose 150 units of food. If you choose 150 units of food, times 2 is what? That one too would give us 600. So, but if you go for B, 100 units of food should give us 200. Okay, 200. And then for shelter to price times this quantity, when we add it, should give us 500. So when the person goes for bundle B, then it's within the opportunity set. If you go for 50 units of food, that is giving us 100 on food, and then 5 units of shelter, that should be 500. If you add the two, you are getting 600. That one too is more than the income. So we should go for B. That's number 13. All right, number 14.
If the price of one good increases, while the price of the other good and the consumer's income remain unchanged, what will happen to the budget line?
Okay, so assuming we have this, okay, and then this is our initial budget line, and then the price of good X. Oh, yeah, what man? Yo. Oh, sorry. This is our initial budget line. Okay, this is good X. Now, there is an increase in the price of good X, right? So this is what happens. The budget line will rotate inward, okay, about the axis of the good whose prices is still the same. Okay, so the budget line rotates inward from the intercept on the axis of the good that did not change in price. Okay, so this one is only the price of good X that is increasing. The consumer's income is constant, and then the price of Y2 is constant. So we go for D. Number 15.
If the prices of both goods and income increase by the same percentage, what will happen to the budget line?
All right, when you get to 400, you'll be asked to find the Marshallian demand function and to prove that the Marshallian demand function is homogeneous of the degree 0. What it means is that if income and then the prices are supposed to move in the same direction and by the same proportion of percentage, there will be no change in the consumer's demand at all. So if income should increase by 100%, and then the price of the two goods should increase by 100%, there will be no change in the budget line at all. You can just use hypothetical values for the prices and income, draw your budget line, and then see what happens. Assuming your income is 10, okay, and then P1 is giving us 1, and then P2 is giving us 2. Let's draw the budget line for this info. Income is 10. So if you want to consume only good 1, we'll consume 10 units, right? Income over price, so 10. If you want to consume only good 2, we'll consume 10 divided by 2, which is 5. So this is going to be our budget line, the initial one. Now income is increasing by 100%, so income will now be 20. P1 will increase by 100%, that should go to 2, and then P2 will increase by 100, so that should go to say 4. So now if you want to buy only good 1, that will be 20 divided by 2, it is still 10. And then if you want to buy only good 2, it should still be 20 divided by 4, and that is still 5. So you see that there will be no change in the budget line at all. Okay, so if they are all moving in the same direction and by the same proportion, there will be no change in the budget line. Okay, so the budget line, nothing is going to happen. What will happen to the budget line? Nothing. Nothing will happen to the budget line. That is 15. I hope we understand. All right, now